So we heard a little bit about risk, and now we're going to hear a little bit more about risk. And what's important to understand about looking at risk is it's typically a function of consequences. What are the economic human events that can occur? What are the vulnerabilities, and what are the threats and hazards that are out there? And we certainly heard some of the threats and potential risk in global markets, but there's a lot of risks that take place when we look at domestic markets. We heard some of the discussion of that earlier today. Our next presentation is what threats pose the greatest risk to energy infrastructure and understanding regional perspectives. We have with us today Dr. Steve Folga, who is the Senior Manager in the Infrastructure Assurance Center at Argonne National Laboratories. He's been involved in this work for the last 12 years related to infrastructure assurance. He's also developed methodologies for estimating potential consequence components of disruptions and the time needed to return a disrupted component into service, which is very important as we look at resiliency, which is trying to estimate the time, reduce the time required to bring things back to normal. So this will give you some regional perspectives across the country on some of the risks that we see in the energy infrastructure. So join me in welcoming Steve Folga to the podium.
Thank you very much, Jeff, and I'd like to thank DOE, OE, EIA, and NASEO for having me here, and especially to Alice for being able to support and to give guidance to this entire project. So, okay. So the overall presentations can be broken out into individual pieces, such as, first off, we're going to be talking about energy risk and giving a definition for that. Looking at the regional breakdown in terms of pads, and then try to determine using NOAA data what are the major natural disasters that occur in each of these individual pads. Then relate that over to each of the individual energy subsectors, electric, natural gas, and petroleum. Gather that information, show which of the actual natural hazards are reflected in the risk profiles for each individual state and region, and then come up with some conclusions associated with that. So in our world, similar to what Jeff was talking about, risk is the potential for an unwanted outcome, which could be such as a loss of natural gas deliveries to an individual area of the country, a number of people losing their electric power. And so it itself is a function of three different components of threat, which is the likelihood, vulnerability, the susceptibility of that individual sector to that type of threat, and the consequence, which is what we all see most every day. But also people have actually talked about risk in terms of both frequency of occurrence and consequence. So that figure on the bottom right-hand side shows you that the greatest risk occurs when you have an overlap of both the threat on the top, the vulnerability on the right, as well as the consequence on the left. And so that's what we're looking for, is looking for those points at which we actually see the greatest energy risk associated for a region of a country or even for a state for the three different subsectors of electric, petroleum, and natural gas. So right now I've just been told by Alice that there's a number of these energy profiles for the different regions are available on the OE website. I don't have the link on it, but I guess if you go to the OE website, you'll be able to get the information about the different regions. And so what they actually show in them is there's a portion of it that actually identifies the states that are associated with the region. It gives information about the energy infrastructure within the state. Then you go down into the bottom right-hand side, there's the information about the natural disasters, which are the most prominent that occur within that region of the country. And then there's breakdowns in terms of maps showing the infrastructures of concern, as well as information, a breakdown of the information of the, like on the electric sector between transmission, distribution. And similarly, information is provided for natural gas and petroleum. And from this, there are actually data associated with weather is also provided, so you could actually look and see whether or not winter weather has any kind of impact on the different infrastructures that we're talking about. Now, Similarly, there's a series of profiles for each individual state, for all 50 states, District of Columbia. That URL at the top shows you where the location of that information is at. And so, as such, this is, I think, a wealth of information that could be used to be able to identify what are the hazards associated with, for each individual state, and how does that actually reflect over on the consequences for these different infrastructures. So what we did was to take data from all different various sources and then break it down into regions. And so the regional breakdown that we used were the 5 pads, which are shown over here in that figure on the right-hand side. And so the pads themselves were developed for petroleum. They're the Petroleum Administration for Defense Districts. And pad 1 is the East Coast, which extends from Maine down to Florida. Pad 2 is the Midwest, where I come from. Pad 3, Gulf Coast. Pad 4, Rocky Mountains. And Pad 5 is the West Coast, including both Alaska and Hawaii. And so we'll be showing data at this regional level, and also we'll show some data also at the FEMA region level. There's 10 of those, so you could get a compare and contrast to see that what we see at this regional breakdown is similar to that you would see if you go into a more detailed FEMA region approach. So now, NOAA's very good. The National Climatic Data Center collects a lot of data. And so what we did is we took all that data since from 1986 to 2014, looked through that, and then try to identify what are the major threats that have occurred, both natural disasters and weather extremes, within the 5 different regions. So the table up on the top, the columns are each of the individual pads going from Pad 1, which is East Coast, all the way to Pad 5, which is the West Coast. And the columns underneath that are the ranking by property damage, where number 1 is, of course, the predominant one down to number 5. And what we did was take the data that they provide in that data set, and the property damage was escalated using the GDP deflator, to account for inflation over that time period. So we're talking today a lot about winter conditions. And so if you look on that figure, wow, the colors have changed. It should be a very bright winter storm. If you go to to Pad 1, it should have been an extremely bright yellow color, and hurricane's now extremely bright yellow color. Oh well, but you'll see by looking at, for this table, that the winter storms and extreme weather actually occupy for Pads 1, 2, 4, and 5, either the 4th or the 5th location amongst all the individual disasters that provide the greatest risk to the United States. But as such, they're not as predominant as, say, these summer type events such as the flood, hurricanes, thunderstorms. So in general, winter storms are a major threat in, say, 4 of the 5 regions of this country, but they're not as predominating, they're not as important, I would say, as the other types of threats such as flood, hurricane, and others which occur during more of the summertime periods. So now if we were to take that information, and please remember that, and we'll take a look at what are the information for the electric grid and the bulk power system within the United States. Well, NERC has a lot of data that they've collected over a number of years since 1992 to 2009, and that's approximately 941 events. And what we did is we binned those individual events into the standard NERC hazard classes. And that's shown here within this table on the far right-hand side. And again, the columns are each of the individual regions of the country, and the rows are actually the ranking associated with that. Now, based on the data that NERC has provided, if you go and look at the 3rd column under Pad 2, right here, that's winter storm. So winter storm is actually identified as a major threat for the bulk power system within the Midwest, my area of the country. But also, there's also another one that actually exists that's weather-related, winter weather-related. If you go to Pad 4, under the 2nd row, maybe you should check to see if we actually have a pointer. It doesn't show. But that's a fuel supply deficiency. If you delve into what that actually means, what that is that's actually natural gas well freeze-offs, coal piles that are frozen within the Rocky Mountain states. And so that's also something that's winter weather related. So you can see that in general, a lot of the individual threats that are seen over in the different parts of the country may not actually be winter weather related, but at least for the Midwest as well as for the Rocky Mountains, weather is actually an important factor in the operation of the bulk power system in this region of the country. Now, if we were to go to the distribution, now distribution is important because this is actually where we see a large amount of the actual outages. When you have a bad outage, it actually can start over on the transmission side. But when you look at it, these little amounts of smaller events that affect a large number of customers, they could linger for a large amount of time, so that you actually have like potentially something in the order of like 90% of the bad things that happen on the electric side actually occur over in the distribution. So the data on the right-hand side is taken for each of the individual regions of the country. Again, you have the ranking. And as you expect, weather and bad weather together with trees, falling trees, vegetation is the single most predominant hazard that actually is reflected in our data set for 2008 to 2014. Now, so that shows for not only for the East Coast, but all the way over into the Rocky Mountain regions. And this is different. Actually, this has changed since our last presentation. When you look at the 2013 data, the Rocky Mountain region was, at that point, for them, it was actually the predominant was the faulty equipment hazard. And faulty equipment means things such as you could have a fire, say like in an underground fault, a substation, a cable fault. You could have a breaker failure, something that actually affects the overall distribution system. And that only appears over on the West Coast and Pad 5 on the far right-hand side. Now, bad weather can occur not only during the summer months, but it also occurs during the winter months. We were unable to break the data down to actually look at what's the amount of percentage that occurs during summer and winter. But we do know, looking at the data from NOAA, that we actually do have winter storms are a major factor both in Pad 1, 2, 4, and 5. So we would suspect that those outages that you see over on the distribution side, a portion of that are due to winter weather. But the only outlier being the West Coast, where they're actually, for them, the major aspect of them is failure of their equipment. If we go into a little bit greater detail, we could try to determine what are the regions that are most at risk from electric distribution outages. And so the U.S. is sort of unique in a certain sense because we have a large number of outages that occur in our system and our distribution system relative to its size. And so this is from an actual New York Post article from a few months ago where they said that basically that the U.S. power grid has the most customer outages per year for its economic size. And we're seeing about 2,000 to 3,000 outages. And so that's between about 12 to 42 million people. And that upper range is when you start seeing things like Hurricane Sandy hitting this area of the country, where you're seeing like 10 million people knocked out at a given time. And so as such, that's reflected within the data up on the upper right-hand side, which shows the number of incidents that occurred as the second column, the annualized total number of customers, and lastly, what's the amount of time it typically would take to actually bring that system back up again. So the East Coast is one of the areas that's most subject to winter weather, and it also has in our data set around 10.3 million customers that are being affected. But primarily by looking into the data, we saw that was generally due to Hurricanes Irene as well as Superstorm Sandy. And so by taking that information and then looking at it on a monthly basis, which is the figure on the bottom right-hand side, we could be able to determine which of the individual months do we actually see the greatest number of electric distribution outages. So It might be hard to see, but the upper blue line is the East Coast. The orange line, wow, the colors have changed a lot. And I'm a typical man, so I can't figure out what the colors are. I need my wife to tell me what the color is. But the second line that you see, which is like the bright orange line, is the Midwest, followed by the West Coast. And we have the months going from 1 to 12, where 1 is January, 12, of course, is December. And for the East, Gulf, and Midwest, the most number of outages occurs during the summer months, between 6 and 8. And only over in the pads 4 and 5, which is Rocky Mountains and West Coast, we actually see it during the fall, winter months. So there is a potential impact, a contributing factor of winter weather to the outages that occur over a distribution level within both the Plain states, which is the Rocky Mountains, as well as the West Coast states. Now, if we were to take this data and break it down in terms of the 10 FEMA regions, which a lot of people like to talk about, here are the 10 FEMA regions, and the green color is shows it's an outage due to, the primary outage is due to bad weather or falling trees. The gray-blue color is actually between a faulty equipment, and the bar itself actually shows you the average number of customers each year that gets affected by electric outages. Some pretty relatively large looking numbers. You can see, like, in general, about 4 million people within the Region 9 are actually affected by electric outages. Similarly, you can see the numbers throughout the different parts of the country. But then you could, by looking at this, the areas that are most subject to winter weather, which are like Region 10, or where Mark is at, all right, the Midwest region, Region 5, and the others over at the East Coast, those are actually affected, again, by vegetation as well as bad weather, which includes winter weather. It's only in the Plain states, which is Region 8 and Region 9, do we actually see no impact of, less of an impact of bad weather. Now, if we could look at a different energy sector, which is petroleum, as our illustrative speaker told us, is unique in that actually it's being brought in by can be actually transported by many different modes, by rail, truck, pipeline, and water. What we're going to try to show here is some data that's been taken for rail and truck on the upper left-hand side, and the one on the bottom right-hand side is a pipeline information. And again, we have data that shows, as a function of the individual regions of the country, the ranking by economic loss for the different types of hazards. And in general, for rail and truck, it's really basically collisions and rollovers. And for them, we hear this all the time. We hear of all sorts of accidents occurring with crude oil, say up here in Quebec, which kill like 40 plus people. So these events occur on a routine basis, not only within the rail industry as well as on the truck. But those are not really weather related, because that can occur independent of weather conditions. They can exacerbate the conditions, but it really doesn't depend on it. Similarly, then, we have a series of other events that could be weather related, which are natural forces, but when we looked into the data set, primarily that's actually due to major events, such as earthquakes, floods, and sometimes even lightning, that actually could cause individual rail cars to actually derail, and then you would have a major spill and a major impact on the rail transportation of crude oil, or now even refined products, as we're seeing more and more within this country. Then when we go over to the right-hand side on the bottom and looking at pipelines, the pipelines themselves are really independent. The forces that affect them are really independent of weather conditions. You have things such as corrosion, You have well failures, which do increase during cold weather conditions, I do agree, but it really takes extreme cold weather for that actually to be a contributing factor, as well as outside forces where you have somebody who actually has a backhoe comes in, hits a pipeline, causes a hole in the ground, and that leads to a major spill. Natural forces here, again, we're similarly a situation where you're looking at earthquakes, floods, lightning, things that actually can cause massive damage over a short, within a large area of the country, which leads to major breakages of the pipeline industry. So in general, the pipelines themselves, as well as rail and truck, are really not, the data indicates they're not really adversely affected to a great degree by winter weather. It can be a contributing factor, but it's not a primary factor. So breaking down the data in terms of the economic losses here on this figure for the individual regions of the country, the right-hand value here is the product pipeline, and the left value is actually the crude oil pipeline. So refined on the right, crude on the left. And you could get an idea of the individual economic losses associated with different areas of the country. And so as such, in general, you see that the Gulf Coast on the refined product side has the greatest amount of losses. But that's not due to winter weather. They've never had winter weather down the Gulf Coast. So it's really not going to be adversely impacted by if the weather turns out bad or the better weather turns out well during the winter season. Over on the crude oil side, you could look and see over for PADD 2, which is the Midwest, that actually has the highest value of all of the crude oil annualized losses. But that's actually due to one event, which affected Jeff's wonderful state of Michigan. He probably was there at the time, which is the Kalamazoo River spill. That was $800 million. It was a very nasty event, very, how can I say it required very extensive response and restoration after the fact. So in general, what we see with respect of the pipeline impacts, it's primarily due to the number of miles of pipeline that are available. So that and the reason why is because if you have more pipelines and you have people going around trying to dig holes in the ground, they hit it. If you have more pipelines, you have more failures, therefore more losses. Now, looking at refineries themselves, which is something that people worry about a lot, this is the data that's been taken out of information that DOE OE provides on their website. We just collected all that information and then binned it together into the different regions of the country. And again, the major impacts associated on the petroleum refining industry are primarily equipment failure or damage, maintenance or turnaround. Those occur typically every 3 to 5 years. You actually have somebody, the individual refineries have to go and do maintenance of their system, and then they turn around things such as catalysts and other types of consumables that need to be replaced, as well as fire and explosion over in the Rocky Mountain regions. But in general, most of these are really independent of any kind of weather effects. And really, when there was the polar vortex occurred over in this area of the country, as well as in the Midwest, there was only one refinery that was affected, and it was the Paulsboro refinery, and it failed because it lost electricity. It wasn't because of the actual cold weather. Some refineries did reduce runs, but other refineries did not shut down. There was only one refinery that was adversely affected by cold weather, so we can think in the future that they would not be much of an impact of the winter weather on this upcoming refinery operations within the United States. Now, that's not to say that bad things happen over at petroleum refineries. A lot of things happen at petroleum refineries. And if you look at the data sets, you'll see typically there's around 600 to 700 incidents that occur at the refineries within the United States every year. So you're talking about 2 per day. And those things could be very minor. Some of them could be very fairly major. A lot of them actually occur, though, because of maintenance, that they bring down the plant for individual parts of their plant for maintenance purposes. And that was the occurrence over in 2013 when we saw approximately 1,300 refinery incidents, and most of those were actually just maintenance and turnaround activities at the various refineries in the United States. But what's really important is that in this is not the actual number of incidents, which is the second column here on the right. If you actually go all the way to the far right-hand side, which shows the percent of refinery capacity that's actually lost during a typical event. And we're looking on the order of about 8 to 9% for the East Coast, for the Midwest PAD 2, as well as for the Rocky Mountain states. So at a given time, if you've got a refinery incident, you're talking potentially about 8 to 9% of your refinery capacity is lost at that point. And that's why you start seeing major price spikes in those regions of the country. If you look, it's less over in the Gulf Coast, which is the PAD 3, and in the West Coast, because they have a multiplicity of refineries that are available. In the event that you do actually have a incident, it's not as difficult for them to recompensate for that. Now, natural gas is a major component, and it's really of importance during the cold weather period of times. Natural gas pipelines are running at their highest utilization rates, and so it's really important to understand what are the major threats associated with them, especially during winter conditions. And so this is data that was taken from the Department of Transportation from 1984 to 2014, and it shows you the different hazards associated with the different regions. And so 3 of the regions are actually affected, the PAD 2, 3, and 4. The major threat to them is outside force. And what that means is basically somebody coming by and using a backhoe or something similar to break into pipelines. It's your Julie system, it's your 411 that you have at your individual states that allow you to be able to, for somebody to actually determine where a pipeline is located so as not to break it. Now, over in PAD 5, it's material weld failures. In that area, they had a large amount of cast iron pipe, very old cast iron pipe from the 1970s, not very good. That basically, they've been finding out that they have to replace that. While over in PAD 1, it's a little bit of, it's really unknown what it is. There's really no data available about it. But you can see in general, it's mostly outside forces as well as natural forces are a major component of the risks associated to natural gas transport. That's both transmission as well as distribution in the individual regions of the country. And natural forces are generally on the natural gas side, they're just primarily flooding as well as lightning and also earthquake. If we break down the economic losses associated with these individual incidents, you'll see a figure similar to this, where you'll have it as a function of the different regions, and the right-hand value is the transmission, and the left-hand value is transmission. Right-hand value, which is the green one, is the distribution. And if you look, you'll see for pads 1, 2, and 3, the transmission numbers are almost exactly the same. And you would say, oh, okay, is there a weather impact of that? Winter weather? Well, Gulf Coast, no winter weather. So basically what it is again, you have a large amount of pipelines available in tightly congested areas where people could actually break them. And that's what the problem is those third-party damage that affects the pipeline industry on the transmission side. Distribution side, the greatest distribution losses are over in the Gulf Coast as well as the West Coast. Again, areas that are not that much subject to winter weather. So for them, it's a situation where, as you would expect, the natural gas infrastructure is not very negatively impacted by winter weather conditions. In fact, that's when it's actually needed at most. It has to be the most reliable under those conditions to provide gas for delivery to ultimate customers like you and me. So, in conclusion, well, these regional risk profiles are available for the 5 regions that we talked about. It's possible to do them also for 10 FEMA regions or to do it for the NERC regions or whatever parts of the country. But these are the regions what we showed here from going of the 5 pads are available now on the DOE website, and they provide information about the major threats and hazards that are affecting the electric natural gas and petroleum industries within each of these individual regions. They complement the state-level profiles that were developed for all 50 states as well as the District of Columbia. And you'll see that the energy sector has a different number of hazards associated with that, but it's been only on the electric side that we actually see some sort of impact from winter weather. We saw from the Midwest on the bulk power system. We saw the winter weather was a major factor, as well as for the Rocky Mountain states. It was under fuel disruption, fuel insufficiency. So we didn't see much of an impact of winter weather on transport of petroleum products, refineries, as well as natural gas transport. And so this information is available as such, and it could be used to actually, if you go into details, we actually could use that kind of information to look at what are the potential impacts, say, of potential future climate change scenarios, to be able to get a better understanding of how the system has reacted in the past and how that would actually react in the future. So I'd like to thank you for your time, and look forward to your questions and comments. Thank you.
Does the data get down to duration of storm impacts, say if there's storms, duration of incidents? Can you drill down to that level?
Yes, we did. So that there's data sets that actually identify, say, on the electric side primarily, where you actually could tell when the storm hit and then when they actually brought back their last customer. And so DOE has a Form 417 that it's available on their website. It goes from 2014, and it's a running list of all the major electric outages that have occurred in the country from 2000 to the present. And in it, they actually do identify what's the amount of time it takes to bring back individual, how can I say it, bring back the system back to normal operating conditions. And it turned out that things such as ice storms are actually the worst ones. Those are the ones that could cause the greatest damage. So historically, you could think of something like during the 1990s, I think 1998, that we had the Great American Ice Storm, and it affected this area of the country. Some of the locations, I think in Kentucky, it took them 3 months to get back the electricity because the ice was like 2-inch thick, and they had a cold weather right after that, and so there was no way of being able to get to those customers. So that data does exist and allows you to be able to figure out, duration versus magnitude.
Steve, I had a question about the aging infrastructure, because I think I could see sort of a trend in some of that data that suggested that the eastern U.S., where the infrastructure by and large is older than the West, there
Right.
seemed to be more equipment failure types of incidents. They were higher on the list. Is that correct?
That is correct. It's an issue that's been was highlighted in the QER, and I know different states have looked at that. Especially, for me, it's mostly on the natural gas side, and so you'll see that, like I said, that there's some pipe that's been put in the ground which is aging. In Chicago, they've dug up pipe recently for natural gas that's wooden. What they took is a log and they drilled through it. And so when they were looking at a portion of the downtown region, they dug it up and they're saying, what the heck is this? It was a wooden log. So how old do you think that is? That's got to be over 120 plus years old. So aging infrastructure is a major concern.
Great. So I have a question about so the analysis is done at regional level and I assume state level. Are you aware of any active examples like state or regional metropolitan area planning agency taking your analysis and doing an active implementation to address their future risks?
No, I am not. There is a potential project that's going to be looking at taking similar information like this at the state level. And so there is, I believe, a project under Department of Energy to look at that and to try to identify at the state level what are the threats, and then try to determine what resilience enhancement options. But that's as much as I know about that project at this point, I'm sorry to say. We did talk with, there's an Hampton Roads initiative. I believe that was set up by a presidential order, and so so we're talking to them under DHS auspices to be able to use this type of data to be able to try to determine what issues could be rectified in terms of like hazards, aging infrastructure, as well as potential climate change impacts in the future. Yes, sir.
Yeah, back on slide 8, I think you had, back on slide 8, I think you had one characterization was attack.
Yes, sir.
Yeah, physical impact or attack. Can you explain that?
Oh.
Under pad 4.
Ye-
bottom.
Yeah, that's within the West Coast region, including Pad 4. There was a series of attacks, I guess you would call it, where somebody was actually taking out the bolts on transmission towers, and then they would leave one of the bolts available. Would leave the bolt. So it's happening in California in different areas. I know PG&E was one of the BPA, that's correct. And so what people were doing, assailants unknown, is they were attacking transmission towers and similar type of electric transmission components. And it was a physical attack. And so what they were waiting for is that they would take out the bolts, take out 3 of the 4 bolts, and then they would wait till the wind to come, and then, the damn thing would fall over. And who's going to even see it? I mean, even when you do a flyover, you can't tell. So that's the type of physical attacks that we're talking about here. So I would call it more than vandalism. It's more like sabotage. Did I answer your question? Oh, okay. You're welcome.
Well, thank you, Steve.